Hello everyone, and welcome back to another quiz tutorial, guide, solution, whatever you want to call it. In this tutorial, we're going to be covering an orthonormal basis. And an orthonormal basis is very important because it's typically the basis set that we use for most of our problems moving forward. The good thing is, it's actually really easy. As you guys will see, there's two main properties of an orthonormal basis, and they're easy to remember and very easy to prove and stuff like that. So, there's not really much to say about it. Let's jump into the theory so you guys can have a better understanding of what exactly an orthonormal basis is. So to be an orthonormal basis set, all of the vectors within that set must exhibit two properties. The first one is all of the basis vectors must have a norm of 1. It could be a norm, magnitude, length, whatever you want to call it. Either way, the norm has to be 1. So the norm of E1 is equal to the norm of E2, equal to the norm of E3, which is equal to 1. So that's a very nice property because it's very, very easy to prove, very, very easy to check if you're given a situation you have to determine if a basis set is orthonormal or not. The second one is that all the vectors in the basis set have to be orthogonal. And that's great because if they're orthogonal or perpendicular, it means that the angle between them is 90 degrees. And if the angle between them is 90 degrees, then the dot product of those vectors must be equal to 0. So E1 dot E2 must be equal to E2 dot E3, which is equal to E1 dot E3, which is, of course, equal to 0. Now, you guys may be wondering, Clayton, these properties are nice and easy, but what does this actually mean? What does this represent physically? Well, if we were to look at R2, and we had the orthonormal basis vectors E1 and E2, it's going to look something like this, where they're perpendicular to each other, have a norm of 1. And this might look familiar to you guys. This looks like the standard XY plane that we're so used to dealing with in math. And that's why orthonormal bases are so important, because they're actually what we use very typically for all scenarios, because they're very easy to define and very easy to make linear combinations of things. So even though the terminology orthonormal basis might be new to you guys, what they actually are is something you guys have dealt with quite a bit. We can also expand this into 3 dimensions by adding that third E3 vector. And again, you guys have probably seen this a lot, maybe not in high school, but definitely in Eng 130 when you had the IJK or the XYZ coordinate system. So again, something you guys have probably seen a lot before. Now we're just kind of defining what exactly it is. So for the questions in this quiz, we're going to go through a bunch of vector sets and we're going to determine, do they form an orthonormal basis or not? So let's jump right into the questions. All right, so the quiz is very simple. It has one question. It says, indicate if the following sets are orthonormal basis sets, which is O and B, or if they're not, of course. So if we look at number 8, the set B is made up of two vectors, x and y, where x is equal to 1, 0, and y is equal to 0, 4. So again, to check if it's an orthonormal basis set, we check two things. One, is the norm of all the vectors equal to 1, and are the vectors themselves perpendicular to each other? So right away in this question, it should be very easy to tell that this is not an orthonormal basis set. And the reason why is because if we look at the norm of y, which is equal to the square root of the component squared, so we're going to have 0 squared plus 4 squared, we can easily tell that the norm of y is equal to 4, and that's not equal to 1. So because of this right here, we can conclude right away that A is not an orthonormal basis. So that's how easy it is. We just have to check one of the two properties, and I always recommend checking the norm first, because the norm will always give it away really, really fast. So if we move on to question B, we have x, which is still equal to 1, 0, but now y is changed to 0, 1. And just by inspection, it's very, very easy to tell that the norm of both of these vectors is equal to 1. So the question we have to ask ourselves are these vectors perpendicular? So if I were to go x dot y, and you guys have probably already see the answer already, this is going to be equal to 1 times 0 plus 0 times 1. And of course this is equal to 0, so therefore the vectors are perpendicular. And since they have a norm of 1, so I'm going to also put that the norm of x is equal to the norm of y, which is equal to 1. These vectors do form an orthonormal basis set. So I can conclude that these are an orthonormal basis. Oops, kind of went off to the side there a bit. All right, so as you guys can see, these are very fast questions, and hopefully you get them on the midterm because it's very quick to solve, stuff like that. So the next one, x and y, they changed it up a little bit. So x is equal to 1 over root 2, And the y component, I guess the second component of it is 1 over root 2. And y is negative 1 over root 2, negative 1 over root 2. So I'll let you guys check really quick, but it's easy to see that x, or the norm of x, is equal to the norm of y, which is equal to 1. If you guys are ever given kind of one of those weird fractions, it usually means that the norm is going to be equal to 1. So that property is good to go. Now the question becomes, are these vectors themselves perpendicular? So if we go x dot y, what we get is we get 1 over root 2 multiplied by the first component of the y, which is negative 1 over root 2. And then we go to the second component. So the second component of x is 1 over root 2. And then we multiply that by the second component of y, which is negative 1 over root 2. And we not substitute, but if we simplify this a little bit, what we get is negative 1/2 minus 1/2. I was going to say negative 1/2, but I already fixed it. So this is equal to negative 1. And if we look, well, we need them to be equal to 0. So since it's not equal to 0, these vectors are not perpendicular. So therefore, this basis set is not orthonormal. So not ONB. So we're going through this really fast. We'll move on to the next one. And as you guys can see, it's the same vectors. So we already know that the norm of x is going to be equal to the norm of y, which is going to be equal to 1. So this is good. The only thing that's changed is that the second component of y, and I'm not sure how this will highlight, the second component of y doesn't have a negative sign anymore. So now when we go x dot y, which is equal to the first component, so we got 1 over root 2, multiplied by the first component of y, which is negative 1 over root 2. And then we go plus, and then the second component, so we got 1 over root 2. But now here's the difference. Instead of multiplying this by negative 1 over root 2, this is just multiplied by 1 over root 2. So what ends up happening is we have 1/2 plus negative 1/2. So in the end, this is equal to 0. So in this case, these two vectors are perpendicular. Therefore, this basis is actually orthonormal. So therefore, we have an orthonormal basis set from these two vectors. So nice and easy. And we take these same properties and we apply it going all the way through. So here's kind of a fun one where we have cosine of 30 and sine of 30. And it's actually very easy to show that these do have a norm of 1. So let's look at x really quick. So the norm of x is equal to the square root of x1 squared. So we have cosine, and I'm not going to put 30. I'm just going to put cosine of theta squared plus, and then the second component is sine. And again, I'll just put theta squared. Well, if you guys remember from trigonometry, cosine squared plus sine squared, that's equal to 1. So this is equal to the root of 1, which is just equal to 1. And since y is the exact same, we also know that this is the norm of y. So the first property checks out. Both x and y have a norm of 1. Now the question becomes, are they perpendicular? So we go to the second property, so x dot y, and in this case, what we're going to have is we're going to have cosine of 30. So cosine of 30, and then we multiply this by negative cosine of 30. And we go to the second component, so we got plus the sine of 30. And then we multiply this by the second component of y, which is, again, sine of 30. And if you guys do the math, I'll just give you a hint. Just throw it in your calculator. Don't try and solve it in your head. I know that you guys can. I don't question it, but a calculator is much more reliable from my experience. I've had really bad experiences. You get that this is equal to negative 0.5. And since this is not equal to 0, these vectors are not perpendicular. So therefore, this is not an orthonormal basis set. Not. All right, so those are the two-dimensional vectors. Now we're going to move on to the three-dimensional vectors, and these are basically just as easy. The only difference is we're going to have to check 3 vectors instead of 2. So the first thing I see is, again, we're always checking the norm first, and if we look at y, we can easily see that the norm of y is equal to 4. So this is not equal to 1. Therefore, this is not an orthonormal basis set, just by that alone. So not ONB. The reason why, again, is because of y. Just because y violates it, everything else kind of goes to crap. It's not an orthonormal basis, thanks to y. So, last question. Again, if you're dealing with these kind of weird fractions, it's kind of a hint that it's probably going to be a norm of 1. So I'll let you guys prove it if you guys want by yourselves, but it's very easily shown that the norm of x in this case is equal to the norm of y, which is equal to the norm of z, which is equal to 1. So the first property is satisfied by all three of the vectors. Now here's the question, are all of the vectors perpendicular to each other? And if we look at this, what we're basically going to have to do is the dot product 3 times. We're going to have to do x dot y is equal to 0, x dot z is equal to 0, and y dot z is equal to 0. So that's one way. However, this is very easily shown that if we dot x with y, it's going to be 0, because if we go x and y right here, it's going to be 1 over root 2 times 0 is 0. Then we're going to have 1 times 0 is 0. And then we're going to have negative 1 over root 2 times 0 is 0. So we already know really quick by inspection that x dot y is equal to 0. And the same thing with y and z, just because they have the opposite components. And I forgot something in z. Sorry. There's actually a 0 right there. So if we were to look at the same thing, well, the first component's multiplied by a 0, so it's going to be 0. The second component is multiplied by a 0, so it's 0. And then the third component's also multiplied by 0, so this is 0. So we conclude just by inspection that x dot y and x dot z, y dot z, let me erase that really quick, y dot z are equal to 0. So the only thing that we're going to have to check that's not extremely obvious is what happens when we dot x and z together. So if we go x dot z, we're just going to go through all the terms. Oh, sorry, scroll down too far. So the first component of x is 1 over root 2. First component of z is negative 1 over root 2. And we're going to go to the second component, and luckily for us, they're both 0, so we're going to have 0 multiplied by 0. And we're going to go to the third component, which is negative 1 over root 2. And then we're multiplying this again by negative 1 over root 2. So from the first components, we get that this is equal to negative 0.5 plus 0 plus 0.5. We add all those together, this is equal to 0. We could conclude from this that all the vectors are perpendicular. Therefore, in this case, this is an orthonormal basis set. So the question's not hard. Again, this is why you hope it's on your midterm. It's very easy to go through all these and just check, is it orthonormal? Is it not orthonormal? And the way to do that, you just check the norm, and then you check if they're perpendicular. So that concludes this quiz. Hopefully this video helped. I really hope it helped, because again, this is easy marks. I want you guys to get those easy marks on your midterms and on your finals. So thank you guys so much for listening. I'll see you guys in quiz number 7.